We can solve this by using substitution. If we were to set u to be equal to 1 plus tan x, then the differential of this is sec squared x. The 1 differentiates to make 0, the tan x differentiates to make sec squared x. And that's useful because, or rather this substitution is useful because the dx, when you replace it, you'd end up dividing the whole integral by sec squared x. And so this sec squared x and this sec squared x will cancel. This root of 1 plus tan x becomes root u. And the tan x that we have here, that will become u minus 1, rearranging this here. So let's put that all in. This then becomes the integral of sec squared x times u minus 1 times u to the half, that's the 1 plus tan x square rooted, that's u to the power of a half. And the dx becomes, so rearranging this, dx is equal to 1 over sec squared x du, so times that in, or bring that in, 1 over sec squared x du. These two sec squared x's then cancel, and this then becomes the integral of, so now we can multiply these two things out. So it becomes the integral of u to the power of 3 over 2 minus u to the half du. And now we can integrate each term. So if we were to have set to begin with u to be equal to tan x, which you could also potentially do, then this becomes u. Again, the differential of tan x is sec squared x, so then the sec squared x would go away. This bit here would then become u multiplied by 1 plus u to the power of a half. Now, this is not as useful as the form that we have it in here, because we can't multiply this out because of the power of a half. This we can multiply out because we have power of 1 here, so this multiplies out to make this, and then we can integrate each individual term. This here we can't multiply out, so we'd have to use substitution one more time after that. Hence why it's better to use this substitution instead of u is equal to tan x. Okay, now we just integrate. So u to the power of 5 over 2 divided by 5 over 2 minus u to the power of 3 over 2 divided by 3 over 2. And we can replace the u with 1 plus tan x, and that will be our final answer. So we could leave it at that. I'm going to factorize this to get it in a form where some questions ask you to leave it in. A lot of students struggle with this factorization, so hopefully this is useful. So there's a common factor of u to the power of 3 over 2. We can take that out from these two. And then there's the fractions. How do we take out something from these two fractions? So how it works when you have fractions is, for the numerator, you take the highest common factor. So the highest common factor of 2 and 2, which is just 2. And for the denominator, you take out the lowest common multiple. So the lowest common multiple of these two is 15. So it'll be 2 over 15 u to the power of 3 over 2. This is what we're taking out from these two terms. Okay, so now to take out the 2 over 15 u to the power of 3 over 2. So the number that we'd have in front would be 3, because 3 divided by 15 is just 1 over 5. Or you can look at it as 3 multiplied by this is just 2 over 5. We'd have to multiply that by u because this is u to the power of 1. Those two powers add up to make 5 over 2. And our next term would be minus 5. 5 over 15 is 1 over 3. So it's this plus c, and then we can replace the u back with 1 plus tan x. So 2 over 15, 1 plus tan x to the power of 3 over 2, 3 times 1 plus tan x, minus 5. So let's just tidy this up a bit. 2 over 15, 1 plus tan x to the power of 3 over 2. And then we can simplify this bracket that we have here. So the 3 times tan x would just be 3 tan x. And then we have 3, those two make 3, minus 5, which is just minus 2 plus c. So again, we don't have to do that. If the question asks for it, obviously you would. But we could have stopped here and just replaced all the u's with 1 plus tan x, and that would be fine. I was just showing you this manipulation because it sometimes comes up and students often find it tricky.